Hello, this is All Your Dev. This is a channel aimed at existing programmers of all skill levels to learn new technologies, mostly programming related. Could be operating system optimization, DevOps, that kind of stuff. But the goal here is mainly to teach new things. This series that I'm doing, this is the first video of, is called Rust Simplified. And the way the format of this series will be is each episode will target one area in Rust to focus on. And the beginning of the episode will focus on a simple aspect, the simplest thing I could teach from it. And then as the episode goes on, it goes into higher level understandings. So beginners would get more from the beginning of the episodes. And as you go on, the more you know, the more you can to learn from it. And you can always come back and check it out and experiment and learn by trying. So that's the format. That's the series, and this series and all other series. There can be many other series on this channel because it's All Your Dev. This is all supported by viewers like you on Patreon. So let's get started with, let's see, with Rust. Now here, this is, let me show you, this is play.rustlang, or rust-lang.org as the website. It lets you write Rust right on the website and then see the results immediately. So if you go ahead and click run, it executes the code, and below you see the output. And if there's any bugs, it'll give you information there you can use. So this is quite handy. And we are going to start with teaching pattern matching in Rust. And the first thing is structuring and destructuring assignment. So structuring assignment is basically you're creating something out of multiple things. You're creating a structure, as it were, of things together. And destructuring is taking those things that were put together and then taking them back out. So first we'll use a tuple. And in Rust you assign variables with let. Actually here we're going to have to do it inside main. You can't do it outside main unless it's a library. So for programs that run, we're going to give this a variable name. Let it'll confuse JavaScript programmers. Let thing, we'll call it thing. Let thing equal, and we're going to give this tuple 3 values, for example. And in Rust, if you want to display something, a native type, then you will use the print line command, and they have a debug option, which is confusing when you first look at it. But you have to do this. Typically, if you're going to print something normally, like this, you just say hello world. If I run this, it'll just say hello world. It takes this and it inserts it inside the mustaches, or the curly braces, whatever you call it. So if I hit this, it'll run hello world. Oh yeah, if you're not using something, Rust complains and lets you know, which is quite helpful. So you put an underscore in front of it, and you don't need to worry about it. So here we go, hello world. Quite nice. Now if you wanted to see more information about it, you do the debug print line format. You hit run, and now we will see quotes around it. So we understand it's a string format of sorts. So now we will put the variable in here, and since we're going to use it, we will remove the underscore and type thing. So that's how you look at something. And we haven't destructured anything, we've only created the structure. So this is structuring assignment. You're assigning a variable here called thing, and you created a structure which is a tuple. You get the regular braces, and we have 3 numbers in it. Now for destructuring assignment, you basically just flip it around. So we're going to do let, put the tuple here first, and we're going to create 3 new variable names. So we'll call it A, B, and C equals thing. Alright, and we're just going to look at what A is first. We need this and A. Probably should put that there. Hit run, and we will see, again, if we're not using it, put it underscore in front of it. Alright, we have a number 1. The first item which was put into thing in a tuple, the first item of a tuple, was then extracted from the same tuple by matching thing directly into A, 1 to A, 2 to B, 3 to C. Now if we wanted to print all 3, we can get fancy with this print line feature and do it like this. And now we can print 3 things and have dashes in between. So I hit run. Here we go. 1, 2, 3. So now you've done structuring assignment here on this line, and you've done destructuring assignment on this line. Now in Rust, they have something that's very similar to a tuple, and it's called a named struct or a named tuple. You probably call it a named struct though if you use it. And basically, you, with a capital letter and a word beforehand, so we're going to call this structure because that makes sense. So now, have we created structure? I don't think we've created structure yet. Let's see what the debug says. Not found in scope. Okay, so we want to define struct first. So we do it outside of main. We'll do struct structure, and it takes 3 arguments, and we will give, this is the type of number we're going to have stored in it. usize is a system unique size. It could be 32-bit, 64-bit. If you have a 32-bit operating system, it'll be a 32-bit size. You don't really need to know that at this point, but now structure exists. So now when we assign it, when we create a structure with structuring assignment, this thing will work, but this part will not work because this is not the same as a tuple. It is now its own unique thing. So we hit run, it'll fail because expected structure found tuple. Very helpful message. So we go in here and we fix it, we write structure, run again, and there you go. It's working again. So now we've done structuring assignment with a regular tuple, and we've done structuring assignment with a named struct. And here's where we defined that struct with the struct keyword, the name of the struct we're using, and the types we're putting inside of it. So now that that's the simple part. That's the easy part. The next part is more advanced, and we're going to get to how you use that in kind of like if-else logic or case switching, that kind of thing. So let's start with, let's just keep this. Let's remove the destructuring, and this actually might be easier if we use something called an enum. So this is a new type, and I know I'm teaching a lot right here. We'll call it enum structure. Change the existing name of this to A. So, and then indent this and change that to a comma, and we're going to copy this line. Structure B will have 2 items in it, and we'll add one more. Structure C, C will have 1 item in it, and it's okay to leave the end comma here. It's quite common in Rust. Now let's try this. Let's make sure we know, make sure it still works. Let's change the printing to print one item in debug format so we can see clearly what's going on here. Print thing. And this is now struct A. So if we hit run, that should work. Or I could be wrong. Expected identifier found keyword. Expected identifier expected. Alright, and this is where you should know what you're talking about before you teach it. Let's see. Expected one of this. So what if I remove this? Let's assume it understands that. Structure cannot be formatted. Oh, now we're on to something. So now this message is helping us by saying that, hey, look, it doesn't implement standard format debug. And in Rust, to print things using this debug helper here in print line, you need to have debug implemented for it. And Rust offers us this nice handy thing called Derive. And I think Derive debug. I think that's the right way to do it. It'll let me know if it's not. Variant is never constructed. Okay, so now we have a warning. Warn dead code on by default. So what we're going to do is we're going to add allow to the beginning of the script. I'm covering a lot that is not directly related to what I'm trying to teach here. But that is fine. We're going to go in here, I'm going to say allow. And when you want to allow something for the entire program, you put it at the beginning of the program, and you do a bash bang. Now if I run this, there we go. Print line printed thing, and we could see that it is an enum of type A. Technically this is still a named struct. So it's a named struct with 3 items. Now that we have this, we can go into the switching logic. We will do match first. Alright, so match thing. We're going to change thing up now and then. And if it is an item of, I wonder if this will work this way. I'm learning too. I've been working in Rust for 2 years and there's still things I haven't tried. Alright, so we're going to do 3 items here, and we only care about the first item. So we're going to give it a name and then 2 underscores because we don't care for the other things. And once that pattern is matched, an item with 3 things in it, then we're going to execute this code block on the right side of the fat arrow. And we're just going to say print line and semicolon first item found. So we don't even care what's in it. If that's the case, we should underscore it. And when you do this, you need to always have, if nothing else happens, do something else. So underscore in a match block helps with that. Fat arrow, and I'm just going to say panic. And then just say everything is on fire. Alright, let's remove this and see what happens when we run it. Run. Expected enum structure found tuple. Okay, that's right. So when you're matching an option, you have some and you have none. Let's see if I try A, if that works. Not found in this scope. Okay. Structure A. First item found. Okay, so that works. If we wanted it in the scope, let's see. I've stepped away from Rust for a few weeks, so it's surprising some of the things that get a little hazy. Let's try use structure. And now let's try it. Not found as use. Yeah, create. So that's the new. That's a new syntax. It's an epoch thing. It's a Rust versioning thing. They have a new format of how things are done. So that should work. Structure A. Oh, okay. Got it. So we want to have at least A here like this. This is what they're asking for. So we're using this so A is publicly available to us to use within the scope of the code we're doing. But I'm going to go ahead and put them all in here with the mustaches or curly braces. We'll do A, B, and C. Now if I run it, okay. Now since we're not using it, it's very nice. This is a nice thing. It's saying, hey, you're using this. You're saying you're using this, but you're not using this. This helps you have much cleaner code and not do things you're not using. You don't have dead code. You don't have unused imports, that kind of thing. But for this example, we're going to allow it. Allow. Alright, run. There we go, first item found. Alright. So now the tuple's working, the named tuple and the match pattern. Let's create some other lines, and let's rename it B with 2 items, and C, oops, C with 1 item. Oops, beforehand underscore. What did I do? Scrolled. Cut. Come on, Vim. Using Vim keys. Second item found. That's one nice thing about this website. They let you use your preferred console editor. Most, well, the main ones. Third. Oops. Third. Alright, so you now run and she'll still come up with the same thing. Unreachable pattern. Okay, why is this unreachable? Because we've covered every possible iteration of what the structure is. So there's only A, B, and C. If we commented this one out and we ran it, it won't panic or it won't complain, because the only thing left is for it to be the structure type C, the named struct C from structure. So this will be third item found. So let's go ahead and prove it. Let's move this down 1 line. Alright, let's change this to B. Actually, now that we're using this, we don't have to write structure here. So we'll just do B and do 1, 2, hit run. Second item found, and then when we use C, it will use the anything other than A and B that happens goes to this. Oh, and I'm still panicking, so we don't want to panic, do we? Current line. Another nice thing, you'll notice I'm using curly braces for this. That's the code block. You don't have to do a code block if you're just doing one thing. You could just do that, which is a little cleaner. Alright, so now we wanted to do C with 1 item, third item found, and now if we get rid of this line and then comment this line, run it again, same thing, third item found. So that's the basic matching possible things from structure. I'm just using this as an example. The more beneficial example, okay, so now you see what an enum is, and it has multiple types in it. The enum you will use most often, there are 2 of them. There's option and result. An option, actually let's put the structure back here. So an option looks much like option function. You have sum, and then there's some kind of thing in it. It might have some weird syntax like that. But the idea is T stands for it could be anything. But when you do that, there are extra things you have to do and learn. We won't cover that this time. But basically, there's some and there's none. And what this is basically Rust's way around having to deal with nil or null or anything like that. You have a path with something and a path with nothing. The other one I told you is result, and result has an OK result or an error result. And an error result can have an error in it, which is useful information. So just like before, you have multiple things that could show up, and you can match according to those types with OK, OK, and if not, it's an error. So we'll just say panic. So yeah, this is matching thing against, we're not using that. And we'll just say okay. The thing okay, and we will write okay. Okay. Hit run. First I have to remove this. You get what a result is. Now in Rust, it automatically includes a few core things in the environment, so you don't have to use the use keyword to bring in result or option. So this, it knows it is, here I'll show you. When you do an assignment, you can say what kind of type it is. So this is the result. Let's hit run. Expected 2 type arguments. Okay, so that's that thing I said we weren't really going to quite cover. So the type, we're going to put a usize, and we don't care about the other one. That's some sort of error. Can't infer type for E. Okay, let's just give it a usize. That's basically since I said I don't care, it still needs to know for when it compiles, it has to know sizes. So we'll just say it's another number. Error will be a number. Alright, we're okay. Now if I said it's an error here, everything will blow up. Yep, it ran because we panicked at explicit panic. That was our panic here, and we can even give it a message. Oh no! Hit run. Main panicked at oh no. So useful message. So this is where the logic comes in of having an enum with multiple structs in it that help you. So you can have a result. If the code is happy and you have an okay, happy path to follow, you can say, if it's okay, then do this good thing. Handle the data, do what I want. But if it happens not to be okay, I want an error returned, and I want useful information with that, and I will choose what to do with it. So you write programs for both. Now, since I've been using underscores here in the mash, you haven't seen how to use it. So I'm going to use A now. This is the destructuring assignment, like we went over earlier. So just the way you took 1, 2, and 3 out of a tuple earlier into A, B, and C, now we are taking the OK result out of the result enum, assigning it to A, and A will be available in the code block here. So we can do a print line, and then we want to show what A is, so we just do A. So that should work. We just got to make this OK. Okay, hit run. Yep, there we go. It is OK, and let's add a little message just so we can see it works. And then show the value. It worked. See? So we created the item. Here, we can remove this type information because it infers the type in this example. You don't need to always explicitly tell it what type it is, since it already knows this type. So now we hit run, it's the same thing. Okay, it's not. It's not the same thing. I misspoke. but there are times it can infer things. Just like we did earlier with numbers and tuples. It inferred those. So, yeah, that's why. Because it can infer the type for E. If there happened to be an error, it needs to know the type information during compile time. So to make it simple, let's just use sum and none. So it's an option type now. And an option type, there is no E for error. The other one, none, has nothing to hold. So now if I run this, it should work. There we go. It worked. So the key difference there is a result needs to know the type that the error will contain, even if you're just returning an OK result. So you have to give it type information like we did earlier. And with an option, it only needs to know the type that's inside of the sum result, or at least something it can infer, like this. It might be an I size, it might be a U size. It determines when it compiles what's best for the program. Alright, so that's the simple match conditioning logic between what to do. The other one here would be none. You run this, it'll still work. Alright, and now if we don't have anything to give it, it's a none result. That's, instead of using nil, we don't need these up here. We can hit run. Cannot infer type. Oh, that's right. Like I said earlier with E, the E inferred. Now we don't have sum inferred, so it's an option, and the type inside will be a U size. There we go. Now hit run. There we go. Main panicked at oh no. So we got the second path. It matched to none. Ran the code after the fat arrow. So this is the simple way to do things. A more complex way, a more advanced way, yes, we're getting deeper into the rabbit hole here, is to use something called if-let. So you know what if you program, you know what if is. If this is true, then do the following. And you already see here what a let assignment is. Let thing equal what's on the other side of the equal sign. So an if-let is kind of like only doing one of these and not having to care about the other one. So you don't have to worry about the second one. You only do one of them. So we're going to do it this way. We're going to do if let sum A equals thing, then I think I'm doing it right. Oops. It worked. Okay. So the idea is we're doing destructuring assignment. We're taking the item on the right and we're passing it. We're taking what's inside the sum out of it into the variable A. And then A we can use inside this code block, starting here at this curly brace and ending here. We may need a semicolon here. We may not. Let me try. So since this is none right now, nothing will print. Nothing printed. Alright, so now let's change this to sum. And I'm going to give it 1, 2, 3, 4. And we don't need my type information because it's now inferred since it has this number type here. Hit run. It worked. 1, 2, 3, 4. So I said it was a little more complicated, a little more advanced. It actually looks simpler, but I learned it much later than learning match. Match is one of the most basic things that you go through. You handle all possible permutations of a result from an enum. This good path, or like our structure enum earlier, where we had A, B, C, we'd have to handle all possible situations for A or B or C. And this, the if-let, you only have to worry about one thing. So that's handy. And that is most of what you need to know for pattern matching in Rust. The only other pattern matching that comes to mind to me at the moment, I'm sure there's things I haven't covered, but in macros there is pattern matching, and we won't be covering macros for some time. Well, anyway, that pretty much sums up this pattern matching episode, starting with structuring assignment and destructuring assignment, going into how enums are, how you can how they're made, how you can use them, and how to apply those in a situation where you're matching different code paths of logic for happy path or not happy path or multiple paths, and then simply just handling one path if that's all you want to do. And so yep, that's pretty deep for a first episode of Rust Simplified, but I think it's good. Let me know what you think. Comment below, let me know what you think, and subscribe please, and share this with people who you think will be interested, or in forums, or with groups or something like that. I really appreciate it. And this series, not just this series, but this channel is also how I will be putting food on my table and keeping a roof over my head. So if you find it in your heart that you want to support me, I would appreciate it. And if this was valuable to you, then all the more reason to see more episodes come about. So thank you for your consideration with that. What would you like to see next? Comment below. I would love to hear what you're interested in learning, and I will do my best to help who I can. Later.